Okay, the next one is a little bit more difficult. It looks easier, but it has a little kink in it that throws things off. The original problem says 2k over n, and knowing that delta x is 1 over n, delta x is 1 over n, then I need this to say k times delta x. So let's fix it to where it says, well, k times delta x. So let's do that. Here's delta x, and there's k, but there was a 2 there. So we have, whoops. That should say 1 over n. So there's a little bit of rearranging that takes place here. So what was on the paper becomes this. This is going to help us identify pieces and parts and those kinds of things. Walk over here for just a second. If delta x is 1 over n, then b minus a is 1. And here's what that means. Final answer for the definite integral part. This definite integral is going to have an interval that has a width of 1. So whatever this is 1 unit further from it. And we don't know the function yet either, but we're about to figure it out. All right, here we go. On the previous problem, we had cosine of a whole bunch of stuff. And now I'm tempted to look at this and say, oh, well, here is a, and there's k delta x, and everything's fine. No, this 2 messes everything up. Messes everything up. And so our input really is just this. That 2 changes things just enough to where I can't identify the specific parts and say, you're this and you're this, and no, that 2 is there. So this is my input, whereas all of this was my input. So let's rearrange this. My input is really just this part right here, which means following the same format, it is 0 plus k delta x, which tells me this. I know I start at 0. Well, what about this one? Hold that thought. Hold that thought. I start at 0, and because the width of the interval is 1, b minus a is 1, that's 1. So now the question is, what's the function? Well, the function is, well, 1 plus 2 times my input. Don't make that harder than it is. 1 plus 2x is the function. And it starts left side at the understood 0 because this was my input. The 2 changes all of that. It's a tricky one, I know. Let's do a left Riemann sum on this one. A left Riemann sum. And we can do the same format we did a minute ago, where we can say, oh, well, let's just do, let's switch colors again. We can do the limit as n approaches infinity of k equals 0 to n of all the same stuff that we had, 2k and then 1 over n, and then 1 over n, there we go. Or we could have it start at 1, like we normally do. So it's the limit as n approaches infinity from 1 to n of 1 plus 2. Okay, I don't want k here. I want to reset it back 1. And so instead of k, I'm going to put k minus 1. And then I'll put 1 over n, and then 1 over n. There we go. There's your left Riemann sum. Again, this 2 changes what you would consider your input to be. So I feel the need to explain it one more time. It's a confusing idea. F of your function. What is my input? My input needs to contain delta x, which I can very easily identify to be 1 over n. That is my input. I need a k with it. But because of this 2, I can't say that my a is 1, the k is the k, the 1 over x. Then who's taking care of the 2? This is my input. And because this is my input, and it should be this big, a is 0.